Hello everyone, this is Kinjal Parmar. In previous session we discussed about analog to digital converter, in which we discussed about various types of analog to digital converter. In previous session we discussed about successive approximation analog to digital converter. In this session we will discuss about another type of analog to digital converter, that is counter type analog to digital converter. We have a total four type of analog to digital converter. In previous sessions we discussed these two types of converter, that is flash comparator type analog to digital converter and a successive approximation analog to digital converter. In today's session we will discuss about a counter type analog to digital converter. So let's start. Counter type analog to digital converter. The counter type analog to digital converter employs a binary counter, a voltage comparator, a control circuit, a AND gate, latch and T to A converter. In a counter type analog to digital converter, we have a binary counter. Counter is a circuit, or says counter is a sequential circuit which counts the values. Then we have a voltage comparator which compares the voltage. Then we have a control circuit, AND gate, latch. Latch is basically a device which is used to store the informations, and we have a digital to analog converter. Again, in this counter type analog to digital converter, to convert analog information into digital, we use digital to analog converter. Similarly, in a previous session we used a digital to analog converter in successive approximation type analog to digital converter. It is also called a digital ramp analog to digital converter because the waveform at the output of the digital to analog converter is a step-by-step ramp, that is staircase. Here we have a basically counter type analog to digital converter. So here this binary counter counts the value like 0, 1, 2, 3. So we have a increasing value. So due to this counter type analog to digital converter is known as a digital ramp analog to digital converter because the waveform at the output of the DAC as a step-by-step ramp. For each conversion, the counter has to start from reset only and count up to the point at which the staircase reference voltage reached the analog input voltage. Here we compare a actual analog value to the output of this counter of devices. So we have a conversion. The counter has to start from reset, that is 0 0 0 and so on. According to number of bits we have a total bit pattern. So for the counter we have to start from 0 and counting the values up to which we have a approximate similar value to the analog input voltage. For example, if we have a 17.2 analog voltage, so we have to count up to 17 and after reaching there we have to store that bit into latch and we have to stop binary counter at the 17. So how we can stop this binary counter and how we can calculate this? The principal disadvantage of this type of analog to digital converter is that conversion time depends on the magnitude of analog input. It is quite slow compared to the other but simplest type of analog to digital converter. Here we have a basic diagram of counter type analog to digital converter. In this we have a 8-bit counter type analog to digital converter. So for 8-bit we have a 8-bit counter. This 8-bit counter produces total 8 bit from Q0 to Q7. Now this Q0 to Q7 is given to digital to analog converter to convert this digital information into analog information, and this analog information is compared with the actual analog input, and this actual analog input and the other approximated digital to analog converted analog input is compared, and we have a AND gate over here. So using this AND gate, here we have a positive or a negative value over here, and due to this positive or negative value we can control this clock which is given to counter. As we discussed in a previous session, counter is a device which is used to count the values, and to count the values counter has to use this clock signal, and if counter has a no clock signal, then counter is basically stopped over there, and we have a no further operations. So we have to control this clock with the use of this AND gate. So we have a 8-bit counter which counts the value, then these values can be converted into analog information from this digital to analog converter. Then we compare this two value, and according to this difference we have a positive and negative difference here, and according to this we have a AND gate. So we have a clock signal over here which is controlled. Here this control circuit is used to control these values over here, and output of this 8-bit counter is stored to the 8-bit latch. So at the end of the conversion we have a digital output over the 8-bit latch. Now how this counter type analog to digital circuit can work? For example, we have a says 25.4 volt analog input. Now initially counter is 0, so we have all the bits are 0, so we have a digital to analog converter output as 0. So we have a 25.4 minus 0, so we have a positive difference. So positive difference which is considered as a 1. So 1 into clock, we have a clock over here, so counter has a clock, so counter counts the value 0, then next one. For 1 we have a 1, so 25.4, so we have a positive difference. So again 1, so 1 into clock, so we have again count clock for a 8-bit counter. So similarly this 8-bit counter counts the value up to the 25. So we have a bit over here like 1 0 0 1 1 0 0 0. Basically 1 2 4 8 16 32 64 128. 16 plus 8 25. 16 plus 8 24. 24 plus 1 25. So we have a binary output of this 11001 as a 25. So we have a beats over here 25.4 minus 25. So we have a positive difference. So 1 into clock, we have a clock over here. So this can be count. So we have a value positive over here. So this counter counts the value up to 25. Now next bit, that is a 26. So we have a bits like this 1 and 0. For this we have a here 26 approximated analog output. So 25.4 minus 26. So 1 25.4 minus 26, that means negative difference, that means 0 over here. So 0 into clock, we have a 0. So after 26 we have a no clock signal over here, and as for 26 we have a negative difference. So this control circuit clear the bits of this 26 and we have a original output for a 25 and which is stored into 8-bit latch. So this is how counter type analog to digital converter works. Here we have a analog input and for that analog input we have to count the value approximated equal to this analog input starting from 0 to so on. For example, we have a 9. So from 0, starting from 0 we have a 1, 2 and up to 9 we have a positive difference. Now whenever we have a 10 as a digital to analog converter output, so 9 minus 10 we have a negative difference. So we have a 0 into clock, no clock for a counter, so counter will be stopped. But for this 10 combination we have a this negative difference. So using this control circuit, this bits of 10 can be cleared and we have a further output as a equal to 9 in form of digital form like 1001 for 4-bit counter. Here we consider 8-bit counter. So we have a total 255 values starting from 0 to 255. So using this counter type analog to digital converter, we can convert analog informations into digital informations like using counter. So this is how analog information can be converted into digital form using counter type analog to digital converter. So in today's session, we discussed about counter type analog to digital converter. This counter type analog to digital converter counts the value approximated equal to the analog input using this counter. This counter type analog to digital converter is quite slow because here we have to count the value starting from 0. So whenever we want to convert analog information into digital, we have to start from 0. So this counter type analog to digital converter is quite slow, but we can calculate or says we can count the value up to 16, which is quite faster, or we can calculate easily as a counter type analog to digital converter is quite easy to implement, so or simple. So for a small number of bits we can use this counter type analog to digital converter, but for a more number of bits the conversion type of this counter type analog digital converter is a more. For a less bit we have a less amount of conversion time, but for a large number of bit, for example for 255 or says for 254 or says a value from 200, starting from 200, so we have to count from 0, 1, 2, 3, 4 and so on. So this counter type analog to digital converter is quite slow when we have a more number of bits, but we can easily calculate for a smaller number of bits. So this counter type analog to digital converter is quite slow but relatively easy to produce digital outputs. So in this session we discussed about this counter type analog to digital converter. Thank you.